everyone, welcome back. This is part 4 for the chemical bonding series from grade 11 chemistry. In this video, we're going to focus on covalent bonding. By the end of this video, you should be able to define covalent bonding, describe the formation of covalent bonding, and represent covalent compounds using the Lewis structure. In the previous video, we've discussed about the formation of ionic bonding in terms of energy. We focused on 2 points. The first one being factors affecting ionic bonding, which are ionization energy, electron affinity, and lattice energy. And also we have seen the Born-Haber cycle to calculate lattice energy of ionic compounds. Feel free to go back and watch that if you haven't watched it yet. So to help us understand the formation and the definition of covalent bonding, let's look at these 3 examples. The first one is the fluorine molecule, the second one is oxygen molecule, and the third one is nitrogen molecule, okay? So this will give us a brief understanding in the formation and definition of covalent bonding. Good, let's begin with fluorine molecule. To understand the formation of fluorine molecule, let's first do the electron configuration of fluorine. Its atomic number is 9. The electron configuration will be 2, 7. So now we have 7 electrons in the outermost shell of fluorine. Remember that only the outermost shell electrons participate in the bond formation. So here I have 2 fluorine atoms, the first fluorine and second fluorine. They both have 7 electrons in their last shell. The first fluorine, 1, 2, 3, 4, 5, 6, and 7. The second fluorine, 7 electrons. Now look at this fluorine. It has 7 electrons in its last shell. So what should it do to attain octets or having 8 electrons in the last shell? It needs to share 1 electron with the adjacent fluorine, okay? So these 2 will share electron and their outermost shell will overlap. To make it like this. So in this overlapped region or area, we're going to have 2 electrons, 1 electron from the first fluorine and the other electron from the second fluorine. Now, as you can see, they have shared 2 electrons or 1 pair of electrons. Now for this fluorine, I have 8 electrons. These 2 electrons will count for this fluorine as well as for this chlorine, okay? And then this fluorine again will have 8 electrons. Now I can write this fluorine molecule as fluorine single bond fluorine. So now how is single covalent bond formed when 1 pair of electron is shared? Now let's look at the second example, which is oxygen molecule. Oxygen has atomic number of 8. Its electron configuration will be 2, 6. So what should oxygen do? It needs to gain or share 2 electrons to become stable, or to have 8 electrons in its last shell. Oh, we have 2 oxygens here. How many electrons do we have in their outermost shells? We have 6 electrons each. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, and 5, 6. So what should they do? They need to contribute 2 electrons each to share 2 pairs of electrons. Now, the new structure will be like this. As you can see, these 2 oxygens have attained the octet now. Let's count for this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. And then for this oxygen again, 1, 2, 3, 4, 5, 6, and 7, 8. So both oxygens have attained their octets. This is double bond. How is double bond formed now? When 2 pairs of electrons are shared between 2 atoms. Now let's look at nitrogen molecule. Let's begin from the atomic number of nitrogen, which is 7. The configuration will be 2, 5. Now look at the valence electron of nitrogen. How many electrons does nitrogen need to become stable? It needs 3 electrons. It needs to either gain 3 electrons or share 3 electrons to become stable. Okay, let's begin by writing 2 nitrogens. How many electrons do we have in the last shell? We have 5 electrons for each nitrogen. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now think about what should these 2 nitrogens do to become stable, to have 8 electrons in their last shells. So to contribute 3 electrons each to share 3 pairs of electrons, totally 6 electrons. Okay. Now nitrogen molecule will look something like this. This is nitrogen molecule. As you can see, this is a triple bond. How is a triple bond formed? When 2 elements or 2 atoms share 3 pairs of electrons, we form triple bonds. So this is a single bond, this is double bond, and then this is triple bonds. So covalent bonds can be single, double, or triple, depending on the number of pair of electrons shared between 2 atoms. Is simply how covalent bonding is formed. Now let's define covalent bonding. So you guys pause the video and try to define covalent bonding by yourselves. Okay, now let's define it together. So covalent bonding is an electrostatic force of attraction between the shared pair of electrons and the nuclei of the 2 bonded atoms. So this is electron density region, meaning this is where shared pair of electrons are found. So this shared pair of electrons are attracted by the positively charged nucleus of this fluorine as well as this fluorine. So let's wrap it again. Covalent bonding is an electrostatic force of attraction between the shared pair of electrons and the nuclei of the 2 bonded atoms. The stronger or the higher the number of pair of electrons shared, the stronger the attraction. Meaning a triple bond is stronger than double bond, and double bond is stronger than single bond. Okay, and now let's focus on representing covalent compounds using the Lewis structure. So being able to write the Lewis structure of covalent compounds is very mandatory for you guys. It will help you in predicting the molecular polarity, bond angle, as well as the molecular geometry of a given compound. So you make sure you are able to draw Lewis structure for any covalent compound. So to write the Lewis structure of covalent compounds, we need to follow some steps. We have summarized them into 5 steps. The first step is to determine the total number of valence electrons. Total number of valence electrons in the molecule. Okay, we're going to add the valence electrons of each atom to get the total number of valence electrons. The second step is to draw the skeletal structure. Today, the central position would be taken by the element that is least electronegative or most electropositive. So remember that hydrogen and fluorine can never be central atoms, okay? And the third step is to fulfill the octet of terminal atoms. Again, if hydrogen is one of our terminal atoms, we only need to form one bond to fulfill its octet, okay? The fourth step is to assign pairs of electrons as lone pairs in the central atom, if any. If any pair of electrons is left and put on the terminating atoms, we assign them as lone pairs around the central atom. The fifth step is to make multiple bonds to fulfill the octet of the central atom using the lone pair of electrons from the terminating atom, if necessary. Okay, this is not always needed. We do this if it is necessary. If we cannot follow the octet rule without making multiple bonds. Okay, good. Now let's dive in to writing the structure using the first example, which is ammonia here. In ammonia, we have 1 nitrogen and 3 hydrogens. So the first step is to determine the total number of valence electrons. So the total number of valence electrons goes like this. Nitrogen has valence electrons of 5. How do I know this? Its atomic number is 7. The configuration will be 2, 5. So 5 plus we all know the valence electron of hydrogen is 1, but we have 3 hydrogens here, so I'm going to multiply 3 by 1. So let me add this. 5 plus 3 is 8. Let's divide this 8 by 2. And this will give us 4. Now we're going to have 4 pairs of electrons. Why did I divide it by 2? Because I was pairing these 8 electrons up, okay? So 8 electrons means 4 pair of electrons. Good. Now let's proceed to the second step, which is to draw the skeletal structure. So our central atom in this case will be nitrogen, okay? Because hydrogen can never be a central atom, despite the fact that hydrogen is more positive here or less negative here. We don't put hydrogen as central atom, okay? It's going to be nitrogen. So I'm going to draw nitrogen, hydrogen, hydrogen, hydrogen. And then I'm going to connect them with a single bond by drawing one stick between the atoms, okay? This is the skeletal structure of ammonia. And then the third step goes to fulfill the octet of terminal atoms. Look at our terminal atoms. We have hydrogens, and then we know that hydrogen needs only 2 electrons to become stable or to have full outer configuration. So this stick represents 2 electrons, meaning we're done with step 3 as well. Step 4, assign pair of electrons as lone pairs in the central atom, if any left. So now let's count how many pair of electrons we have used so far. So we have used 1 pair here, 2 and 3 pairs. So totally we had 4 pairs. Now we have used 3 pairs. So 4 minus 3 is 1. Now I have 1 pair of electrons left. So where do I put that? Around the central atom as lone pairs, So what are lone pairs and what are bonding pairs of electrons? This pair of electrons, the ones that are put in the form of stick between the 2 atoms, we call them bonding pairs. Bonding pairs. These are the pair of electrons that participate in the bond formation. And then the electrons that are put around the central atom, we call them lone pairs. Lone pairs. So lone pairs are pair of electrons that did not take part in the bond formation. So for ammonia, I have 1 lone pairs and 3 bonding pairs. 1, 2, 3. 3 bonding pairs and 1 lone pairs. So this is it for the Lewis structure of ammonia. Let me make this clear for you guys. This is the Lewis structure of ammonia. Now let's look at a second example on writing Lewis structures for covalent compounds. This is sulfur trioxide, SO3. Here we have 1 sulfur atom and 3 oxygen atoms. The first step is to determine the total number of valence electrons. So sulfur and oxygen, they are on the same group, which is group 6. So they have 6 electrons in their last shell, okay? If you guys forgot this and you remember the atomic number of sulfur, you can do the electron configuration. Its electron configuration is 2, 8, 6. Now we have 6 electrons in the last shell, okay? For oxygen, its electron configuration is 2, 6. Again, we have 6 electrons in the last shell. But if you guys can remember their position in the periodic table, they are found in group 6, meaning they have 6 electrons in the last shell, okay? Okay, now let's do the total number of valence electrons. I have 1 sulfur, so 1 times 6 plus I have 3 oxygens, so 3 times 6. This would be 6 plus 18, 24 single electrons. Let's pair them up, divided by 2. Now I'm going to have 12 pairs of electrons. The second step is to draw the skeletal structure. Now, which one is going to be my central atom? Obviously sulfur, because oxygen is much more electronegative than sulfur. Or you can also see from the numbers of atoms. We have 1 sulfur that cannot be terminating atoms, comparing it with 3 oxygen atoms, okay? So let's do the Lewis structure now. We have sulfur in the center, and we have 3 oxygen surrounding sulfur. So oxygen needs 8 electrons in its last shell to become stable. As you can see, it only has 2 electrons. So I'm going to add 6 electrons to oxygen. 1, 2, 3, 4, 5, 6. So now let's calculate, or let's check how many pairs of electrons we have used. So in the first bond, we have used 4 pairs. The second bond, 4 pairs. Again, 4. So totally we had 12 pairs, and we have used 12 pairs again. So there is no lone pair of electrons around sulfur. But let's check the octet of the central atom. Does sulfur obey the octet now? How many pair of electrons does it have around its circle? So sulfur has 1, 2, 3, 4, 5, 6, but it should have 8, right? So what we can do here? What we can do is we can make multiple bonds using the pair of electrons, the lone pairs from one of the surrounding atoms, to make a multiple bond to satisfy the octet of the central atom. So look at, you guys can take one of these oxygens. So what I can do is I can transfer these 2 electrons. This is not going to affect the octet of this oxygen, as this is going to be counted for oxygen as well. So now let's check the octet of all the atoms. Oxygen, octets, oxygen, this one, 2, 4, 6, 8, octet, and then this sulfur is octet again. So this is the Lewis structure of sulfur trioxide, or SO3. Now let's look at the number of lone pairs and bonding pairs. Lone pairs of electrons and bonding pairs of electrons. So how many lone pairs do you see around the central atom? Whenever you are asked to determine the total number of, or the number of lone pairs, you have to look at the central atom. Is there any lone pair in the central atom? No. So I say 0 lone pairs, okay? What about bonding pairs? Now count the bonds. A single bond counts as 1 pair. Double bond counts as 2 pairs, okay? So 1, 2, 3, 4. Now I have 4 bonding pairs of electrons. This is the Lewis structure of... Now we have the carbonate ion. What makes this one different is the fact that we have -2 charge here, okay? So what are we going to do with this -2 charge? We'll see it together. Let's begin by step 1, which is to determine the total number of electrons here, the valence electrons. So for carbon, we have 4 electrons, plus for oxygen, we have 6 electrons. 3 times 6, because we have 3 oxygen atoms, and then each has 6 electrons in their valence shell. So 4 plus 3 times 6. Now we have -2 charge. What does this -2 charge mean? So in chemistry, you become a negatively charged ion when you gain or take 2 extra electrons, okay? So this is -2 because this ion has gained 2 extra electrons. Now we're going to add 2 electrons, okay? So 4 plus 3 times 6 plus 2 would be, this is 18, 20, 24. 24 electrons here. Let me divide this by 2 to pair them up. This would be 12 pairs of electrons. We have carbon in the center and 3 oxygens around carbon. Okay. The skeletal structure includes a single bond between these bonded atoms, okay? Let's fulfill the octets. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's continue. Let's check how many pairs of electrons have we used so far? 4, 8, 12. So we had 12 pair of electrons, but we have used again 12 pairs, meaning we don't have any lone pairs of electron around carbon, okay? I'm not going to put pair of electrons around carbon because we don't have any lone pairs. Now let's check the octet of carbon. Count for carbon 2, 4, 6. Carbon has not attained its octet yet. So what can I do? I can make multiple bonds using the lone pairs of electrons on the terminal atoms, okay? So let's choose one of these 3 oxygen atoms. I like to choose the top one. I don't know why. So let's take these 2 electrons, okay? So let's take these 2 electrons and put them as a multiple bond or double bond here. So now the new structure will be, now let's check the octet of carbon. 2, 4, 6, and 8. Now we have attained our octet. Here we had -2 charge. We're not going to forget this. We're going to draw a big square bracket and put this 2 minus charge. It's 2 minus charge. Now this is the Lewis structure for the carbonate ion, okay? Whenever you encounter ions while drawing Lewis structures for covalent compounds, you add the number given here if you have a negative charge, and you subtract the number given here if you have a positive charge. Now what is left? What is left is to determine the number of lone pair electrons and bonding pair electrons. How many lone pairs of electrons do we have? Do we have any lone pairs of electrons around the central atom? No. So I put 0 as lone pairs. And how many bonding pairs do I have? 1, 2, 3, and 4. I have 4 bonding pairs and 0 lone pairs in this case. This is how you write Lewis structures of covalent compounds. Thank you. This is it for part 4. See you guys in the next video. Don't forget to subscribe, like, share, and comment. Thank you again.